They can hear.
Pretty much, yeah. All right, so odds and expectations. So the stuff that we're going to talk now, mainly I just want you to be understanding the difference between odds and what the probabilities are. Because they are just a little bit different.
Oh, I need help figure out loans.
Okay.
I was gonna ask you that. You have an assignment today?
Yes, it should be able to be done in class though. It is 5 questions. All right. So, excuse me. When we're talking odds are going to be things that people use to bet. Okay, I'm just going to say it in those terms. So casinos use it, racetracks use it, other gambling places use it to figure out the payoffs for the bets that they're going to make when those things are purchased. As goofy as it's, or not goofy, as weird as it sounds, insurance companies do it as well. Okay, they're essentially making a bet. I'll use a car insurance. They're making a bet on you that you're not going to get into an accident that they're going to have to pay to fix it. Okay, so that's usually why a younger driver has higher premiums, because the odds of a younger driver getting into an accident are higher than an older experienced driver.
And if you're a guy.
What's that? And if you're a guy. Okay, they take all the things that happen and they're going to figure out the odds, and they realize that usually young guys make poorer decisions than young girls.
Not in my case.
Again, odds are what they are. If you guys watched any basketball, you can probably figure out that the odds of the teams winning has not been too favorable for this bracket this year. So anyway,
Every year it's like over.
Alternator, so yeah.
This.
All right, so anyway, that's what odds are. The odds are kind of that prediction where they're going to put money on one thing to happen over another thing. Okay? So, when we were dealing with probabilities, and I'm going to write this one down. When we dealt with probability, the way it was set up was the favorable over the total. Okay, that's what probability was. If I wanted to really break it down a little bit more, I could say the probability is your favorable. I'm just going to simplify my words so I don't have to write as much. Favorable over the unfavorable plus the favorable. Meaning it's going to be the total amount of things that happen, right? So if I was going to have a dice that got rolled, the probability of it rolling a 1 is it's going to be a 1, because that's what I wanted it to happen, out of 6 total options. Okay? That's what the probability is. But when we deal with the odds, no, I wrote it up, or it's typed up there. But when we deal with the odds are written as the favorable outcomes over the unfavorable. So I'll kind of show you the difference between the probability and the odds. I'm going to write it for kind of rolling that dice. If I roll the dice, I'm going to put it right here. I got the dice. I'm trying to get a 1. Get a 1. My probability of rolling a 1 is going to be 1 over 6. I've got 6 total options. There's only going to be 1 on there. But my odds of rolling a 1 will be 1 to 5. Or I could say 1 over 5. So just to understand, when you have the probability and odds, it's going to be a difference. And if you're trying to calculate using the wrong numbers, then it kind of makes it a little bit harder to get the correct answer. Okay? and to figure out really what that, I'll say, dollar amount is going to mean. So when you deal with odds, so like insurance or gambling, again, I'm not condoning the gambling stuff, but there's going to be different sweepstakes, things like that, that'll say the odds of winning are this, this, and this. Usually the guy talked really, really fast at the end of a commercial. But that's what those odds are meaning. It's going to be your favorable over your unfavorable. So far, so good? Okay. So I'm going to start off with my very first example here. Got a standard deck of cards. I want to find the odds of getting an ace. So let's just start off. I'm going to write those two terms. I have favorable over unfavorable. Looking at that deck of cards, how many aces are there? 4. And now to figure out my unfavorable, I got to figure out what's left. Not the total amount of cards, but how many cards are left after doing that. How many of them are going to be not aces? Perfect, 48. Okay. When it comes time for me to figure out the actual odds, I do need to simplify it down. So I have 1 over 48. I'm going to simplify it down and divide both of those. My odds of getting an ace are going to simplify down to 1 over 12. And I could write it as 1 over 12, or I could say the odds of getting that ace are going to be 1 to 12. Okay, if you're unsure, I'm going to write this in a different color just to kind of show it's a extra little hint to help you out. If you're unsure of how to get the bottom number, you will take your favorable divided by your, I'm going to say your total amount minus the favorable, which is exactly what you did before. Jay, you did in your head. You had 52 minus the 4, and you guys got 48. If you have big numbers, really all you're doing is you're just taking your total amount of choices minus the favorable that's on the top. Where did that one go? All right, let me just write this one in then. I have no idea where it disappeared to. I want to know the odds against getting an ace. And I have no idea where that stuff went.
So you gotta figure out how to do it alone. I'm sure.
Yeah, I'll scroll under there. What are the odds against getting an ace? Okay, you guys talk me through. What am I going to write?
Should we do every other?
Oh, your
But the
thing
four.
is spastic.
Correct.
So it'd be 48.
Fantastic. 48 would be on top. And then what would be my unfavorable on the bottom?
Yeah.
What would 4? So I've got 4 aces. So if there's 48 that are not aces, there's 4 that are aces. So if I'm looking at my odds against it, it would be 12 to 1. This is one of those odds are one of those things that you need to make sure that you keep it kind of over the 1 to let them know that it's going to be that comparison. Okay. So I want to go with the odds in terms of probability. This is going to be the last or not last part, but the other part where they kind of put the two of them together. Okay. So odds in terms of probability. When an event has a favorable and an unfavorable outcome, it's going to be A plus B. That's the total amount of outcomes. This is pretty much kind of what we were doing. I wrote it at the very, very beginning. So if they give you the odds, you can figure out what the actual probability is. And I'll write it on the board just to kind of show this one out off. If you had, let's try to figure out how you do this one. All right, I'm going to go with this one. If you look and see where it says probability is 1 out of 5 and the odds are 1 out of 4, or 1 to 4, I'm letting you know right now these are the same thing. The probability of 1 out of 5 and the odds of 1 to 4 are the exact same thing. But looking at these, if I said your probability to win is this one, or your odds to win are this one, which one looks like you have the better chance of winning? This one looks, again, even though it's the same thing, this one looks like it's a little bit better. So understanding that if they give you the odds, figuring out as a probability gives you a realistic number on what your actual chances are going to be. Okay, and that's what this part is. If they give you the probability, you can turn it into odds. If they give you the odds, make sure that you are able to understand how to get the actual probability. Okay, so for this one, that's the, if it gives you the, in terms of probability, so it's, if they give you the probability, you can figure out the odds. If they give you the, if they give you the odds, that's how you can figure out the probability, and then kind of back and forth. So if I'm looking at this one, I'm going to use that 1 out of 5, 1 out of 4 situation. If I have the probability, my chance of winning, my odds in favor would be 1. Okay? And then I've got, this one, I knew I forgot to write that part down. When they give you the probabilities, why are you not erasing? I'm going to write this one down. When probabilities are given, they will always give as a decimal. That's right. So when they give you the probability, they're going to give it as a decimal. So this 1 out of 5 that I have up here would be written as 0.2 or 20% chance of winning. So when they give you the probability, it's always going to be written as a decimal. That's right. I even wrote notes to myself to make sure I don't forget these parts. So if I'm looking at my probability of winning for this one, I got that 0.2 over the 1 minus 0.2. So my odds are going to be 0.2 over 0.8, simplified down to 1 over 4. Okay, exact same thing that we had up here, where this probability of 1/5, and then my odds of 1/4. That's going to be where those probability numbers come from. Okay? Questions on that part? I'm going to give 2 examples on this one. Okay. So I'll zoom in as best I can so you can see all the stuff as we go through it. All right, so this one is telling me right now, I got the probability. Probability of 0.423 of getting exactly one pair in a 5-card poker hand. Okay, I want to know the odds of getting that one pair, and then I want to find the odds against it. So again, they give me the probability. Now I want to change that into the odds. So to figure this first part out, I have that 0.423 over 1 minus, it's doing that thing again. Give me a sec. Let me try to just delete this thing. Sorry. 1 minus 0.423.
But you have one.
Because I'm going to take it out of 100%. Out of 1. That's where this formula came right there.
Oh,
Because I'm going to give it as a decimal.
I see that now.
Yep. So instead of saying 100 minus the percent, I'm just going to say 1 minus as a decimal. Yep. So the odds of getting exactly one pair would be 0.423 over 0.577. All right. I want to get rid of those decimal places just because I don't like to work with the decimal places. So I'm going to multiply everything times 1,000 just because I want to move that decimal place completely gone. I'm just going to wipe out those decimals. They're in the exact same spot. So I've got 423 over 577. So my odds, if I wanted to put it in a calculator and try to see if it can simplify down, I don't think that one does. I think that's it. Does it?
I'm tired. Oh, much better 10.
Sorry, my calculator is struggling here.
How was yesterday? They looked at me and now they started chasing after me. And my mom didn't believe me. So then I sat in my car, waiting for it to go. When I called her, I said, Mom, can you come outside? There's a cat. She said, no.
423 divided by 577. Yeah, that one's as far as it'll go. That is my simplified odds. Okay, I want you guys to go through. Tell me my odds against. I want to know the odds against getting this.
So just do the opposite.
So 577 over 423.
Yes, you're right. How'd you get it? You're right. You just flip the sides. Again, once you figure out the odds for or to make it for that way, to do the against, you're just flipping them upside down. So if I'm going to say my odds of winning the game are 1 to 4, my odds of losing the game are going to be 4 to 1. Okay? So my odds for this is my 4. This is my against. Would be 577 over 423. Okay, here's where the insurance company is going to start getting into the mix. According to the National Safety Council, the odds of dying due to an injury at some point in your life are 10 to 237. I want to know the probability of dying from that injury. Any thoughts on how I can start to solve that?
Over 1 minus 237.
I'm going to agree with the 10. So the 1 minus is only if they give us the probability first, and then we're trying to find the odds. This one's they're giving us the odds. We want to change the odds into the probability.
Oh, and then if 10 plus 237.
Yes. I'm going to add both those bottom numbers. I'm going to do 10 plus 237. I'm going to add both parts. I'm going to add the front part. I'm going to add the back part. and that's going to be the total amount that I'll have at the bottom. So I get 10 plus 237. My odds turn into, 10 over 240. I can't get right today. 247. I can put it in my calculator. I can simplify that down. Actually, I can't simplify it down. And that's as far as I can go. Okay, I'm going to give you about, I'm going to estimate it here, but the chances if I rounded that up to 25, it's like a 1 in 25 chance of you dying from an injury at some point in your life. Again, it's not saying which specific type of injury, but also there's going to be a lot of little things. Again, nothing for you to worry about right now, but if you get health insurance or life insurance would be the one. Life insurance, a lot of times they will put extra little rules on the bottom there that say we will pay out for an untimely death unless these things happen. So if you are skydiving, a lot of times that doesn't count.
Nobody reads that.
I'm letting you know that's where this stuff comes from. So the people who do those policies look at all these other crazy odds and they find the things that are like risky behaviors, and a lot of times they'll take those things out. One thing that a lot of insurances did is that they have a war clause in there that said if you ever went to war, they're not going to pay it out. So that's why usually like people in the military, we have our own set of insurance specifically because that's a possibility. But like if people are playing with guns, usually that's not one of those that if you're shooting at each other, if you're like in a gang war in the middle of town, they're not going to pay for your insurance if you actually had life insurance. Okay. Questions on the probabilities and odds? All right. This next part will not be testable. I'm letting you know right now, I'm not going to test on it. It's not going to be anywhere else, but I want you to be aware of what it is. Okay? A lot of times just because you're going to see some different odds that people, or not odds, they're going to do some different ways of fundraising. So that way if you're ever going to be in the job of being like a marketing manager of trying to raise funds for whatever group.
That's what I'm doing right now.
And this is going to be your go-to. Yes, ma'am. Yes, ma'am.
We have one today actually at 1,000 degrees, 10% of what they make.
Well, I will tell you kind of how you can do some of the raffles and things like that. Where the numbers are going to come from. Okay, so we've got expected value. All right, I want to explain this one again. Not testable. I just want you to be aware of what it is. Okay, so the next concept is going to be your related odds, the probabilities that you expect, or your expected values. Expected values determine the results that would be expected over a long time, a long term. If the results, in some sort of gamble. Okay, it's not just for a game of chance, but they do things like insurance, management, engineering, other ideas like that. The biggest part is that they can turn those key elements into actual numbers. Did anyone ever get into like playing like the Monopoly at McDonald's game?
Probably my great.
Oh, like the peel the stick.
Yeah.
Oh yes, that was my favorite. That's the only reason why I went to McDonald's.
Yeah, so like those ones, if you ever looked in the back, or like even Burger King, sometimes they have little peel tabs on cups or fries. Sometimes on the back they'll say like the cash value of this is like 1/20th of a cent. Meaning that over the long term, the chances of you actually paying out each one of those is only worth like 1/20th of a cent. Anyway, what you're doing is you're turning those odds, those things into an actual numerical value. Okay, so the one I'm going to jump ahead to, I'm going to skip This is why we're not getting into it. This is the formula that they use for all of it if you have a bunch of different possibilities. Okay? Which turns into a giant headache for right now. I'm not going to get into it. I'm mainly going to show you one or actually two examples, and then I want you to just kind of understand from that. So I wouldn't worry about this formula here, but I will explain it in this formula or this next one right down here. All right, this one says 1,000 tickets are sold at $1 each. Okay, you guys have probably been around a raffle before. Okay, so it's saying 1,000 tickets are sold at $1 each for a color TV valued at $350. Okay, so right away, if you're trying to just figure out from the stance of somebody purchasing a TV, okay, if you win it, you're going to be up $650. Or sorry, $649 because you paid $1 for it, you got $350 TV. Here is the way that using this expected value, this actually works through. All right, so when we look at it, I'm going to put my chance to gain it, and then my chance to lose it. Okay, so I've got a total of $350 minus 1. So this would be like my return on investment. Sorry. So if I paid $1 and the entire thing is going to cost $350, ultimately I'll be up $349. But does that make sense on how if I pay $1, I'm going to make the TV. Essentially, I only paid $1 for it, so I gained an additional $349.
Yeah.
Yeah? If you lose, what'd you pay?
$1.
$1, and that's it. Okay, so that's the first part was if we won it, if we gained it, here's how much money we'd win. If we lost it, here's all we lost. Okay? For this next one, I'm going to go to the probability. So what's the probability of you winning that TV if you buy one ticket? 1 in 1,000. Perfect.
Also depends. Is there 1,000 people?
Yep, this one says 1,000 tickets are sold.
Okay.
This one's saying exactly
Gotcha.
1,000 tickets are sold. Okay? And then what's the probability that you're going to lose?
99.99.
999 over 1,000. That's your probability of losing. Okay? The way that the math is going to work on this one to figure this last part out, we're going to take how much money we'd gain, so $349, times the probability of us actually winning it, plus how much we're going to lose, times the probability of us losing, which is almost guaranteed. It won't move you down. Come on. You can do it. There you go. So I'm going to put these numbers together. I have 349 over 1,000 minus 999 over 1,000. Add straight across, I get negative 650 over 1,000, which simplifies down to negative 0.65. So my expected value, if I buy a ticket, based on the odds, based on the probability, I'm expecting to lose 65 cents every single time I pay that one ticket out. Okay? If we drop down the amount of people down to 500 people, a better chance of winning, this number is going to go down as well. It's going to be a better chance that I will win it. Okay?
No, pretty much it's 65%.
Yeah, kinda. It not really a 65% chance, but it's because again, you have a like 65% per dollar chance, which is it's weird that way. But yeah, this is how much you'd be losing or expecting to lose for each time you paid it. If you were going to run a charity, every single time a person paid a ticket or bought a ticket, you'd be expecting to bring in an extra 65 cents, which seems like a pretty good deal for that one. Does that make sense so far?
Yeah.
Okay, we're gonna do one more, and I want you guys just to talk through it. I just want to do this one because, believe it or not, this actually happens some places. We're gonna buy a house. People will actually do a raffle for a house. A lot of times, these are like newer developments.
Do you pay anything on the house?
Usually, it'll be like the tax when you first start. That's it. So for this thing, it says 10,000 tickets are sold at $50 a piece. Okay, and we're gonna buy a new house. The house is valued at $200,000. What's the expected value if a person purchases 2 tickets? So meaning those 2 tickets that they bought. Again, possibilities aren't, or the probability is not going to be that great, but how much will they really be out, kind of based on how much money the entire house is worth?
100.
Just like the last one, we paid $2. Or sorry, we paid $1, but the expected value of that one ticket was only 65 cents.
50 plus 50 is 100.
Yep, so that's what we're gonna do. We'll go,
I was saying.
okay. So we've got what we're gonna gain versus our loss. Okay, so you're thinking that we're going to gain how much money?
100. 99.
So we're gonna take the total value of the house. Total value of the house minus those 2 tickets. Because we're buying 2 tickets for $100. I am down at 199,900.
That's how much you're gonna gain.
That would be what I would expect to gain.
Okay.
After I paid $100 for my 2 tickets, this is how much I gained. Because again, I already paid that $100 off. How much would I lose if I didn't win? Bought 2 tickets.
100.
$100. Also notice I'm doing these as positive and negative numbers on purpose. Okay, what is my probability of winning? 2 over 10,000. What's my probability of losing?
9,998.
Perfect. Over 10,000. All right. So to figure out what it's actually going to cost, I'm taking that $199,900 times. I'm going to simplify it down. 1 over 5,000. Actually, you know what? I'll do the 10,000 still. Just kidding. 2 over 10,000, because we'll have the same denominator. I can add easier. Plus negative 100. I've made 1,000. Negative 100 times 9,998 over 10,000. So I get, punch these numbers in, 199. I get 399,800 over 10,000 minus 999,800 over 10,000. It's the exact same denominator, so I can subtract them. I get negative 600, negative 600,000 over 10,000. simplified down to negative $60. So after buying 2 tickets, my expected value for each one of those tickets is negative $60. Okay, I'm not worried about the probability of us winning. I'm just trying to figure out what that ticket is actually worth. So if somebody said, hey, tell you what, and this, if you guys have ever had that, it's like, hey, I need to go home early. You want to buy my ticket from me? You guys ever had one of those things?
Or a Muskies game where the people have free tickets, you want one?
Well, I mean, I'm even saying like if somebody bought a raffle ticket and they're trying to say, hey, I have to go home. You want to buy this ticket from me? If someone says, hey, I'll pay you $50 for each one of those tickets, is that a good deal for you?
Yeah.
Technically,
No.
not really, because it's each one of or both those tickets, both of them together cost about $60.
And like the car trip there. And then
Yeah, you're worried about all that other stuff. So we bought 2 tickets. What would 1 ticket be worth?
50.
30.
30. I'm just gonna divide this by 2. So I bought 2 tickets. Each one's gonna be.
I'm not okay.
So again, if you have raffles, if they have things like that, and someone says, hey,
Snowing.
I will pay, or I'll buy that thing off of you, so that way you don't have to pay for it. That's how to figure out what those things are actually going to be worth. Okay, last parts are just some knowledge pieces. Just knowledge pieces I want you to be aware. I don't want you to go and get your kneecaps busted. Okay, sports betting. A lot of times what they do is they'll give you in terms of like $100. There's a commercial going on right now about some sports betting thing.
They're big ones.
I don't even know. But anyway, a lot of times it'll tell you what this stuff means. For example, they'll say team is listed as plus 130 for your odds.
Is that like that sports.com?
Yeah, like those
I
things.
see it all the time.
So I just want to explain what this stuff is. So if a team's listed as plus 130, it means if you bet $100, you would be expected that you would return $130. Meaning, if you bet $100, they would pay you $230. Meaning you got your $100 that you initially bet plus an extra $130. Does that make sense? So that's what that plus numbers mean. If you are doing odds, you have the odds that your team is going to win. You don't have to worry about that out of $100. It's going to be just out of the 1. But your odds, so if it said like 5-1 odds of winning, it means that $1 that you bet, you'd make 6. Okay, you have your $1 originally plus the 5 extra dollars that you'd win. That's what those odds are going to mean. Okay, I just want to make sure you understand what that stuff is. I'm not encouraging you to bet. I just want you to be a knowledgeable consumer. Okay, and then the very last one, sometimes different casinos are going to be required to give data out there on what they're actually doing, what they're actually winning. So in gambling games, they can say an expected value of the gain is $0. Should be fair for you if you go in the casino. Okay. If the value is positive, then that means the player has a better chance of winning. Okay. It has a better than even chance of winning. If it's negative, it's going to be in favor of the house, meaning that the casino will make money. Robert and I were talking about roulette the other day. He said, just put it all in black, you got to roll. Okay? On a roulette wheel, I'm going to have Robert tell you here, because we talked it. Is it perfect odds?
No.
So like if you have like black and red.
And green.
What's this green about?
There's a green 0 and then there's a double green 0 and you have different odds. So like I was in Vegas and I seen somebody put 20 down on the double green. I'm pretty sure it was only 20 and they won 1,000.
Perfect. Yeah, so again, that if you go like if it's gonna say I'm gonna have it all on red or all on black, it's not a 50-50 chance. There's a better chance that the casino is gonna make money because they have an extra one that's neither red nor black. Okay, I can't say if it's odds or evens because they have one that's a 0 that just doesn't count for anything. So it's meant specifically for those people to make some money back. Okay? That's really what I wanted to talk with odds and probabilities. The assignment today, you guys got a lot of time. It's going to be numbers 24, 25, 26. As I'm looking at it, they're all in order. It's 24 to 28. Let me get it.
Get money up the Zelle. I don't know about it. I can show you.
I'm working.
Good, because Harper's gonna be.
666.
Snowing.
I see that.
How am I screaming?
Do you think it's gonna freeze?
No,
Yeah, it is. Do you think it's a stick?
no. But
He said if it's